The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Alright, so I'm going to work through problem number 19 for Physics 2020 Midterm Exam 1. This problem says, the average power developed by lifting a mass of 5 kilograms to a height of 6 meters in a time of 3 seconds. So basically it's asking us to find the average power developed by doing this work. Okay, so we want to find the average power, right? And if we look on our formula sheet, which is given for this particular exam, under conservation of energy, you'll see an equation for power, and power P is defined as work divided by the time, right? And it has units. Work divided by the time has units of watts. Alright? And we know that work is equal to a force times your displacement. Alright? And what's given in this information is that we have mass is equal to 5 kilograms, and we know that the height is going to be 6 meters, and we know that the time is going to be 3 seconds. So if we find the work and divide that by the time, then we actually find the power. So the first thing we need to do is find how much work. And we see here that we have work, so this is work. And work is equal to a force times a displacement. So it's basically the force that you apply, that's applied on a particular object, and the amount of distance that you have, that this force is applied along. Okay, so in this particular case, it's a mass of 5 kilograms, and we're lifting that mass 6 meters in the air, and so you have to apply a force in order to do that, because otherwise the mass will just sit on the ground. So what is that force that you have to apply to that mass? Well, basically that's just equal to a weight force. Okay, so the force in this particular case is a weight force, which is your mass times the acceleration due to gravity. Alright? And so the force is equal to 5 kilograms multiplied by 9.8 meters per second squared, which is your acceleration, and that works out to be 49 kilograms times meters per second squared, which we just call that a Newton. Okay, kilograms, meters per second squared, we just call that a Newton. Alright, so that is our force. We know that the distance that we're applying that force is 6 meters, so now we can find the work. So work is equal to our 49 newtons, okay, multiplied by our distance, which is 6 meters. So the work is equal to 294 joules. Okay? Now, let's say that we have, so now all we need to do is divide this work by the time. So the power now is equal to 294 joules divided by the time, but the time is 3 seconds. All right. So units for power also are joules per second. So the power is equal to .98 watts. Okay? And let me just make sure, because I have a discrepancy in my notes. So, yeah, I wrote it down wrong in my notes. I apologize for that. So, so basically what we had to do to solve this problem is that we had to understand that power is defined as work divided by time. And so we had to find the work that we had to apply onto this, that was applied onto the object, which was 5 kilograms. We did that by calculating the force. It was a weight force. We got 49 newtons. We know that the displacement, when we pushed this object up, was 6 meters. So we actually found the work. Then all we had to do was divide that by the time, and that allows us to calculate the power, which is 98 watts.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.